Welcome back. This is the last and final video on the synthetic routes of ketones. So the first reaction we're going to look at is, again, organometallic. What's organometallic means? Well, again, we have organic, which is compounds containing carbon, or part of the compound contains carbon and hydrogen, but then the remaining part of the reagent also contains metals, copper and lithium. So again, this is an easier way to remember this. Now R is generic, okay, again. So what if R was CH3, CH2, 2, the rest will all be the same, just what's inside the bracket changes. This is what I meant by organometallic. Part of the reagent contains carbon and hydrogen, and that's the organo part. The copper and the lithium are metals, so it's the metallic part, okay, in ether. Again, this R is generic, so is this R. When an acid chloride reacts with an organometallic reagent in the presence of an ether, because, you know, understand this is probably not all that polar, but ether is, so is non-polar. So say this R, let's say it's CH3 COCl, okay, and it reacts with this. This is the reagent, this is the reactant, this is the reagent. All we're doing is, for the product, we're writing a major portion of the reactant the same. Instead of the Cl, we write one of what's inside. See, we have two of these, right? Just write one of it at the end of the chain. Basically, this is the only reaction we have learned in all of 330 and now, up until now at least, where we add carbons to the chain. We've never done that, okay? We've never done that. We've always replaced something, but we kept the carbon count the same. This was the very first time where we add extra carbons to the chain. So basically, whatever is in the ring inside of it, normally it's two of them, you take one of it and then just attach that. So what if it was CH3, 2, Cu1 minus Li plus ether? This is the product of this reaction, okay? Now what if it was CH3 COCl, the same reactant, plus this? The product would be, again, we have only two CH3, so we use only one of that. The major portion of the reactant is the same, and just replace the Cl with the CH3. This is called a symmetrical ketone because groups on either side of the C double bond O is the same. This is an asymmetrical ketone, means the groups on either side of the ketone. So this is the first time where we added a carbon to the chain. Then what we started with two carbons in the reactant, right? Two dots. There are two more dots. Two of them, just use one of the pairs. So we ended up with 1, 2, 3, 4 dots. So we've added two more carbons to the chain. Again, here we started with 2 dots. We had 1 dot to add. So 1, 2, 3 dots total. The math works out, right? So this is the first synthetic, and one of the methods we can synthesize ketone. Is very, very popular in almost any professional exams. And this is another ozonolysis procedure. We learned with the aldehydes, there are two cases, 2 hydrogens on either side or 1 hydrogen on either side. There is no hydrogen on either side of the double bond, then it guarantees a ketone. Again, ozonolysis means O3. So if this reagent were to react with this reactant, all we're going to do is write everything up until the double bond. We break it here, right? We just add a double bond O to this side, plus just like on the other side. I think we learned this in Chem 330. So this is ketone, right? Now, ozonolysis of an alkene with zero hydrogens on one side of the double bond. This is the last of the final combination. Again, this is also a compound by itself, which is very unique. Okay. Again, I can change this side, but so this is technically a possibility on an exam. So again, the side with the two hydrogens will give you an aldehyde, and the side without the hydrogens will give you the ketone. Again, lack of hydrogen is a requirement for ketone. So we break it right here, right? We're adding a double bond over here, plus we're adding a double bond over here. So this is the only case where we produce a ketone and an aldehyde. Similarly, here we produced a ketone and a ketone. So we've looked at two separate cases for aldehydes and two separate cases for ketones. Just look at them. They may look confusing in the first attempt when you try to see this, but it's very, very simple. Okay. Basically, if you don't have any hydrogens on either side of the double bond, you get a ketone. The rest of the times you will have an aldehyde. It's just that simple. All right. So we got one more on synthesis of ketone. Now, if you remember, we learned the BBN and then the H2O2 NaOH, which said it's anti-Markovnikov, right? Same time, this time we have a Markovnikov, which is indicated by the mercury, right? And then R is generic. Say if I have CH3, C triple bond CH, this part will stay the same. I will only change the R part. Now say this reacts with this reagent. In the previous case, we did. In this case, we're going to generate a ketone. So the side with no hydrogen gets a double bond O. We replace a triple bond with a single bond, and then we add two more hydrogens to the side that contained the hydrogen. So these are the ones we've added. Okay, I've circled it just to indicate it. So double bond O goes to the carbon with no hydrogen. Triple bond is replaced by single bond. And the carbon with hydrogen, carbon with hydrogen receives two hydrogens. It's exact opposite. That's what Markovnikov and anti-Markovnikov means, right? So on a test, I could change the CH3 to a CH3, CH2. Well, again, this is not in line structure. In a line structure, it'll look like this: 1, 2, 3. That's it. This is what this compound is, right? This would be 1, 2, 3 dot, right? So 1, 2, 3 dot, and the triple bond would be at the end of the chain. So the triple bond would always be at the end of the chain for this to work. Okay, I can only change one side of the chain. So why don't you practice this using this reagent, this reactant using this reagent? Why don't you try and write the product for it using the rules I've provided here? And that pretty much concludes our synthetic rides of ketones. And I'll see you back with the reactions of aldehydes and ketones. So stay tuned.